Hello, in this video I will show you how to work with the ADL-UT25 thickness gauge and introduce you to its main functions. Let us start with connecting the transducer. Two types of direct ultrasonic transducers are used with the ADL-UT25, single crystal and dual crystal. Let us take a look at the device. The left connector is the transmitter, the right connector is the receiver. If a single crystal transducer is used, it is enough to connect it to the transmitter connector. We connect one end of the cable to the transducer and the other end to the transmitter connector. We use a cable of the same color. If a dual crystal transducer is used, we connect the cable from the transmitter to the upper connector of the transducer and the second cable to the lower connector. Its other end is connected to the receiver connector. After connecting the transducer, we turn on the device. The main screen displays the date, time, and battery charge level. Below that, the selected transducer type is displayed. The device does not have automatic transducer detection, so it must be selected manually. To do this, we open the menu and go to the transducer section. Every transducer has its marking printed on its body. For example, C100, 12, 10 and 6 halves. We find the same number in the list and select it. If the selected model matches the connected transducer, we can start working. Now let us look at the main screen. The measurement result is displayed in the central part. Below that, the unit of measurement is shown millimeters. The next parameter is temperature. The ADL-UT25 has a built-in pyrometer that shows the surface temperature in real time. For example, right now I am measuring the temperature of my hand. The temperature of any other object can be measured in the same way. The next parameter is gain. It is adjusted with the up and down buttons. Gain affects the sensitivity of the transducer. For measuring thin parts, it is recommended to reduce the gain. For thicker parts, it can be increased. After zero calibration, the gain value is set automatically, but it can be adjusted for a specific task if needed. On the right, the current ultrasonic velocity is displayed, and it can also be changed. Now let us move on to the device menu. The first item is a scan. A scan displays the ultrasonic signal and is used to search for defects as well as to display the backwall echo. Let us see how it works. We place the transducer on the sample. A measurement range from 0 to 500 millimeters is currently selected. It can be changed with the range button. The thickness of the sample is 15 millimeters. The reflected signal is shown on the screen, while the measured thickness is displayed at the top. Before starting measurements, the transducer must be calibrated. To do this, we open the Set 0 section. Before performing zero calibration, the surface of the transducer must be clean and dry. Next, we select the sample that will be used for calibration. We press Change. Here the ultrasonic velocity is set. I will perform zero calibration using a step calibration block with steps of 15, 10, 5 and 3 millimeters. After entering the required parameters, we press Save. We check once again that the working surface of the transducer is dry. Now we press Detect while the transducer is in the air and not touching the surface. After that, we place it on the sample and wait for the procedure to finish. When it is finished, we press OK. As you can see, the device correctly determined the thickness of the sample. If the ultrasonic velocity in the material is unknown, but the thickness of the sample is known, the device can automatically determine the ultrasonic propagation velocity. For example, for this 15 mm thick sample, the device determined a velocity of about 6,025 meters per second. After that, measurements of other parts made of the same material can be taken. For example, 10 mm thick. We have finished setting up the transducer. Now let us look at the remaining functions. As already mentioned, a scan mode displays the ultrasonic signal. It can be used to analyze reflections and detect defects. The back wall echo is currently shown on the screen. The ultrasonic wave passes through the material, reflects off the opposite surface and returns back. If the measurement range is increased, subsequent signal reflections can be seen. For example, for a 15 mm thick sample, the values 15, 30, 45, 60, 75 and 90 mm will be displayed. For a 10 mm thick sample, 10, 20, 30 mm and so on. The next mode is B-scan. It is designed to monitor wall thinning in parts such as pipes. During operation due to corrosion or wear, the wall thickness of a pipe may decrease. For monitoring, we start B-scan mode, press start and move the transducer along the surface. The device continuously records the thickness profile. If wall thinning occurs at any section, it is immediately shown on the screen. This way, problem areas can be quickly identified and the necessary measures can be taken in time. All B-scan results can be saved and viewed later. Regular measurements are also stored in the device memory. The next section is the list of compatible transducers. The device supports a large number of models, both single crystal and dual crystal. We have already covered the zero calibration and velocity determination functions. If the ultrasonic velocity is unknown, the built-in material library can be used. It includes steel, aluminum, copper, titanium, and many other materials. After selecting a material, the device will automatically set the corresponding ultrasonic velocity. If needed, the velocity can be set manually. If the required material is not in the library, it can be added manually. To do this, we go to the My Material section, press Select, then Change, enter the required velocity and save the material. After that, it can be quickly selected from the list. The next section is Memory. All completed measurements are stored here. A separate B-scan memory section is used to store results obtained in B-scan mode. The next item is Tolerance. Here the minimum and maximum allowable thickness values are set. If the measurement result goes beyond the set limits, the device will automatically warn the user. Next comes the resolution item. Here you can choose to display results with a precision of 1/10 or 1/100th of a millimeter. The next section is the choice of measurement units. The device supports displaying results in both millimeters and inches. And the last section is general settings. Here you can set the date and time, the automatic shutdown time, the screen brightness, turn sound signals on or off, turn the pyrometer on or off, choose the interface language, and also view information about the device, name, serial number, and software version. That is all. Thank you for your attention.